Good evening. Or we're now reaching into what is called night, good night. And once again, yours truly, Dolphy Gilpin is here with you in Decatur, Georgia, United States of America. I'm on the second floor, 1524 Decatur. I'm continuing now with CME, and tonight, or C stands for chemistry, and we could keep the M for medical, chemical medical education. And just to recap, in the previous lecture, the most recent one, we had come up upon our friend here, the periodic table. And we came upon the periodic table by the magnetization property of our amazing 5x12 matrix, abbreviated the Amz5x12 matrix. We were studying oxygen, and which is abundance and relative to our Amz5x12 matrix. By its magnetization property, we came upon the periodic table, which in essence is a matrix of the form or dimension now 9 by 18. We have now 9 columns and 18 rows, or rather 9 rows and 18 columns. In another format, we had sort of separated the lanthanide series and the actinide series, and we had a specialized 2x14 for the lanthanide and actinide series. And as you will notice, some of these elemental era are blank or void or null. Now, since we are going to be using this periodic table to show our pharmacochemicals synthesis and how they come about, in particular with their microbiology properties and their chemical properties and their pharmacology properties, we are sort of focusing a little bit on the periodic table by itself. And so, in particular, we're going to give a brief history, a personal history, and the history will include now the founders of the periodic table. And let's begin with that. We say now that Alexander Emile B. Concourtois, French geologist and mineralogist, who was studying rocks and geography and geology. He arranged the elements in order of atomic weights in 1862. That's now the French Alexander Emile B. Concourtois. And excuse my pronunciation, this is French, I don't study French. Secondly, now we have the English John Newlands, an English chemist, in 1863. He arranged 56 elements at that time by their characteristic behavior and by their chemical characteristic. He just arranged them by their properties and how they behave. That was the English John Newlands. And third, in Dmitry Mendeleev in 1869, he arranged the 69 elements via their atomic masses. Now, if you ask who discovered the periodic table in most of today's scholars, they will tell you Dmitry Mendeleev. But as you could see, there were others before him and after him that made contribution. And these 4 that I've named are not the only person that made contribution to the development of the periodic table. But usually, Dmitry Mendeleev and John Newlands, and they were attributed in particular to the founding of the periodic table. Now modern, we have Glen T Seaborn, an American chemist. He discovered now the transuranium elements. That is the element coming after uranium-92, with atomic mass 92. He discovered them, and in particular now, americium, curium, californium, and Mendeleevium, and others. He discovered them, and he was granted a Nobel Prize in 1951 for his contribution to the modern development of the modern periodic table in the uranium lanthanide and actinide series. So he discovered 10 of these transuranium elements, and in particular now we could say now that this californium, for example, have 18 isotopes, and it's the symbol CF, and with the half-lives ranging from 42nd to 900 years. And I think the one with 900 years is one of the most stable of the isotope. Yeah, but Glen T Seaborn, he discovered the 10 transuranium elements. That is the elements coming after uranium-92. Now, 2019 was dubbed or declared by the United Nations as the International Year of the Periodic Table of Elements, recognizing now the contribution of chemistry in the universal problem solving problems for humanity. So 2019, which is this year, we're still in 2019, was the International Year of the Periodic Table. So all right, so let's continue with the periodic table. So we have given you a chronological development, history of the periodic table here, sort of genealogy, if you want to call it a mosaic. And personally, I stumbled upon the periodic table here in America in 1976 during my courses of chemistry, pre-medical and pre-engineering and engineering and medical chemistry in 1976 and thereafter 1976 up to my graduation in 1983 with the baccalaureate degree. And so the periodic table was used and applied, and the whole, at that time there was, from 1976, there were 105 elements at that time, and since then the periodic table is extended to about 118 today. And so courses in chemistry at CCNY and laboratory chemistry, organic and inorganic, led to the use and application of the periodic table. Like I said, at that time, the whole spectrum of the periodic table was used. Prior to that, there was only partial amount of the periodic table used in various syllabuses. So that's just a brief history and a prelude to our periodic table. We'll be using it in depth in the form of a chemical synthesis, and sometimes we will not be using just individual pure elements, but compounds consisting of 1, 2, and even 3 elements, or 4 elements sometimes. And usually in the organic sense, sometimes we have up to 3, 4 elements. Usually carbon, nitrogen, oxygen, they are the most, and hydrogen, they are the most frequent use one, with sulfur and phosphorus, and sulfur and phosphorus coming in. Abbreviated CHONPS, CHOMS, carbon, hydrogen, oxygen, nitrogen, P for phosphorus, N and S for sulfur. So they are the most frequent ones, but there are others that will be used. Last time we take a look at the yttrium and its radioactive property and its uses in medicine, in radiotherapy, and in cancer therapy. So yeah, so thereafter now, I continue my personal history. After 1984, we embark upon some specialized organic chemistry courses, Chemistry 362 at CCNY there, and it particularly showed the synthesis now of some pharmacochemical using pharmacology, most organic medical chemistry, and thereafter it was seminars in chemistry through the Graduate Center at CCNY at 42nd Street in New York, and thereby the periodic table was in use again. Well, note that not only chemistry make use of the periodic table, but physicists also make use of the periodic table. And in engineering as well, we make use of the periodic table, but the chemists make use of the periodic table more in depth. In engineering, particularly when we were using uranium and plutonium in nuclear engineering, we had was to use atomic mass and atomic number of the protons, neutron and electron, and fissions and fusions, reaction. And so the periodic table of elements was significant to us, in particular the use of this actinoid series with uranium and plutonium and the various transuranium invention made by Glen T Seaborn, who discovered the transuranium elements. So that's just a brief overview of the periodic table. And once again, we say that we're using our Amz5x12 as a nucleus matrix, and we have expanded stochastically to get a 9 by 18 matrix, which comprises the periodic table. And this 9x12 matrix, in the periodic table, we call the columns as group and the rows as periods. So that if you choose, say, any elements, randomly choose this one, which is, we randomly choose, say, let's use one that we know, nickel. Here it is. We'll say this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10th column. So that will be in group 10. And with rows now, it will be 1, 2, 3, 4. See, be in the fourth row, and that's a period. So it's in column 10 and period 4. Likewise, if you choose yttrium, that would be in column 3 and period 5. Randomly, if you choose carbon, this would be in column 10, 11, 12, 13, 14, 14 and period 2. So the periodic table is described by, we locate elements by their periods and group. So we'll take a break from our periodic table here, and we will return now a little later on with some pharmacochemicals and the Amz5x12 IPCA development.